and mean is quite homogeneous, and we see the spread of scores around the mean. So homogeneity of variances basically it lies on the assumption of t-test, that is independent t-test, and ANOVA, and there what happens is we every time see that is there equal number of variances or not. So here I have come up with this picture. In this picture you can see that there are two groups. This is one part and this is the other part. In this picture only this half. Here you can see that there are two population groups, two samples, and the mean lies over here. The red dotted line, the mean lies over here, and the spread of the population, it is the variance. So whenever the variance is equal and the mean value is not equal, then only we are going to apply the parametric test, that is t-test and ANOVA. And in case of this picture, you can see that variance is not equal and mean value is equal. Then you have to go for non-parametric test, or else you have to remove the outliers from your sample. Here are again other methods for testing homogeneity of variance. Here you can see that we are going with Levene's test, and there are many others like Bartlett's test, Brown-Forsyth test, Welch test, and visual inspection. Now the question that arises is that why is it important? So here you can see that before running ANOVA and t-test, we apply this test to analyze our samples. Whether the mean, simply we see the mean, whether the mean values are equal or not. So this is simply a summary table. Summary table, what it checks? It checks the variances, that is it the equal spread in the groups? Then why it is needed for test like ANOVA and t-test. Here we make the null hypothesis. The null hypothesis is variances are equal and the good result. Here again we have to check upon if our p value is greater than 0.05, then only the null hypothesis will be accepted. In next slide we will see it. Here you can see this point. Null hypothesis says that variances are equal, and alternative hypothesis say variances are not equal. If we have to apply the parametric test, then we have to accept our null hypothesis. So the p value that we will be calculating should be greater than 0.05, then only you can apply the parametric test, that is ANOVA and t-test. So now next, sir will be explaining you about the t-test, the application of t-test through SPSS. So please.
Thank you, Asana. Suppose one of you wants to compare the 50 meters value of the football and hockey players, or vertical jump between football and hockey players. So as for comparing those variables, you have to take data. Suppose you have taken data, but before going for t-test and ANOVA, first of all you have to check variance, like how much the data is spread. Okay, so this is the example for conducting a Levene's test. Moving towards t-test, first of all we have to put this data in SPSS. Here groups are assigned like 1, 2, proportion tab is there. Click on that, then you will find independent sample t-test. In independent sample test, when you click this, this will pop up. Here groups and independent variables are present. As you can see, test variables and grouping variables are ready. So in grouping variables, you have to drag group into that, and in test variable you have to drag dependent variable. We have to name those groups like group 1 and 2 before going there. These groups will be group 1 will be 1 and 2 will be 2. We could continue button. Yes, after clicking on continue, Levene's test will automatically apply. Here two tables are present. First table is of independent sample test, which is Levene's test for equality variance, and at the right corner test for equality of variance. And second table is group statistics, which is distributive statistics. Okay, so in first table significance value is 0.632. It is higher than our null hypothesis significant value, which was 0.05, which means our data is homogeneous. So this is the status. Now, Asan.
So as in t-test, your Levene statistic will be coming directly automatically generated in your the result bar, and in ANOVA you have to check in for the option for homogeneity. So through ANOVA, if you see, first we will be decoding over here. I will be labeling the values over here. I have made 4 groups. Next slide. This is the data set that I have prepared. That is in factor group, I will be the groups that are written over here. And in the dependent list, the scores that I have written, the dependent scores, the options. After clicking options, this dialog box will come. And over here, I will be checking in only the homogeneity of variance, because this is the particular point that we are talking upon. So here we will be checking, and nothing will be done over here. Directly we will continue. And this is the result of the ANOVA data set. So here we can see that homogeneity of variance in the Levene statistic, the significant value is 0.975. So this value states that it is above the p value, that is 0.05. Therefore, our null hypothesis is accepted, and we can further go with the table of ANOVA. Next slide. So these were the 2 methods: homogeneity of Levene's test through dependent t-test and through ANOVA. And these are some pros of Levene's test. It is quite simple to use. Then it's a robust method as well, and applicable to multiple groups. It provides multiple options. Either you can wait on mean. If you have outliers, then you can go with median as well. Next, if we talk about the disadvantages, then these are the disadvantages. It is sensitive to non-normality. Then low power with small sample sizes. Of course, we have to go with large sample sets to generalize our findings. And it does not specify where variance differences exist, and may be unnecessary if variances are obviously equal. So here a best practice tip that I got is that use Levene's test based on median. If you suspect non-normal data, that I already told, that we can perform it on median as well, and always combine it with visual text like box plots, residual plots for a more complete assessment. So that's it. Anyone having any problem or any doubt?